Hey everyone, welcome to Coding Simplified, and today we'll see a very important question in DP. So basically our problem is that we are given a string and we need to find the longest palindromic sequence exists in the string, right? So basically if you say like this is my string, so my string is ABEFBAC, right? It means this is the characters I have. Now if you see, is there any palindromic subsequence? Is there any palindromic sequence, right? So if you observe this one, we have A, B, then E, then B, A, right? So can I say like this is a palindromic subsequence, this A, B, E, then B, A, right? It means A, B, A, B, A can be a palindromic subsequence, right? So guys, there is little bit difference between longest palindromic sequence and longest palindromic substring, right? In substring what happens that it should be the adjacent, right? So like let's say if you find out like what is the longest palindromic substring here, so in this case it has nothing, it has only one, right? Because there is no such longest substring. But if you talk about in sequence, it is not needed that it should be the adjacent. It should not be an adjacent, like it can be in any way, but it should be the palindromic, right? So that is why we have seen that in this string these are the characters which are making the longest palindromic subsequence. So it is sequence or you can say subsequence, right? So that we need to find out like what is the length of this one. So like length is 5, it means my answer should be 5, right? So first of all we'll see that what's the logic to solve this question. After solving this, we'll see that can we apply DP here, right? So DP can be applied if it follows a two property, overlapping subproblem or it has the optimal substructure. So from the basic solution we'll see that whether this solution is following this property, then we'll apply the DP. So first of all we'll see the top to down approach and then we'll see the bottom to up approach, right? So it's very important that you understand the logic first of all, like how we are going to solve this question, and then we'll apply into DP form, right? So let's see the basic solution. So now this is kind of little bit big string. Let's say if I have this one, if my string is B, A, B. Now how many palindromic subsequence it has? It has 3, because all 3 characters can make a palindromic subsequence, right? Now can I do something like this, that I will have one variable here and I will have another variable here, right? Now I will check if the characters at start index and end index are matching. It means I can be sure that there is a palindromic subsequence. Now I need to check further, right? It means if this is matching, if the both characters are matching, then increase the start plus 1 and end minus 1, right? And check further recursively. So let's say if my string was something like this, let's say it has A, B, A, and then C, B, A, right? In this case, if I start from something like this, so my start will be here and my end will be here. Now both start and end are matching. It means we'll say 2 plus, now check recursive 2, why 2? Because 1 for this one, 1 for this one. So we'll say 2 plus, then again we'll increase the start plus 1 and decrease the end. So now my start plus 1 will be pointing to this one, my end will point to this one. So it means now my remaining recursive solution is this one. I will operate this one. Again B and B are matching, right? Again I will do 2 plus and I will increase the start and I will decrease the end. So now it has EC, right? Now EC is not matching. It means I will say that my answer is basically 2 plus 2 and plus we will take one character, right? So out of these two, because out of these two it will give me 1, so it will be 2 plus 2 plus 1, right? So this is the one case. This is the one case when my start and end characters are matching. But let's say if my start and ends are not matching, in this case what you will do? So something like this. Let's say if it was B, A, B and C. Now my start will be here and my end will be here, right? Now I know what is the answer of this solution. If you see exactly, my answer is 3, because BAB is matching the longest palindromic subsequence. So I know that start and ends are not matching. So if start and ends are not matching, I have two options. One option is to check the recursive here, that what is the solution, this one, or I can have the maximum value from here, right? So let's take one more example. Let's say if it was something like this: A, B, A and B, and let's say C and F. Now A and F are not matching. It means either I can have solution into this one, longest Palindrome sequence, or I can have solution into this one, right? So if your start or end the characters are not matching, in this what you will do, you will recursively check first of all for start plus 1 and end, and you will check start and end minus 1, and whichever will give you the maximum value, that will be your answer, right? So it means maximum of this one, right? So what we have understood till now, we have understood that we'll take two variables, start and end. Start will pointing to the first variable, the first character, and end will point to the last character. Now we'll keep on checking the characters, that if start and end characters are matching, then we'll recursively go for the start plus 1 and end minus 1. And if your start and ends are not matching, then we'll check recursively for this one and we'll get the maximum, right? Now when we'll stop, so we will stop because what will happen, that the start will increase to this one and will decrease this one. So we'll basically stop when start will be greater than end, right? Because we know that start is at lower end and end is at bigger end. So when start is greater than end, it means I am done my all the values. So this is the case. Now it can happen one thing, that start and end both are matching at one position. Now if it at one position, it means it can return 1, right? Like this one. So here start and end characters are matching. Now start will be pointing to 1 plus and end will also point to this one. So it means both are pointing to this one. So if both are pointing to a particular value, particular index, it means in this case I can return 1, right? So this is how we have the 4 cases. So let me show you directly the recursive solution, how it will happen. So this is basically the recursive solution I have, and here what I'm doing, I'm passing the string, what is my string, and I'm passing the start. So start is basically the 0, because your starting index is 0 and your end index is your string length or minus 1, because we start from in array, we start basically from the 0. So that is why we say end. So if you see here, you can see that this is how I call the function longest palindromic string app LPS. So here pass the string 0, the first value, and the string of length minus 1, right? So now here I will stop. This is my start, this is my ending condition, that if start is greater than end, then you return the 0, because it means there is nothing value. Now if start is equals to end, it means both are matching at the one position. So in this case I can return 1. Now if your characters at the start and the characters are ends are matching, in this what will return? Will return 2 plus and start plus 1 and end minus 1, right? Or what you do, if your characters are not matching, it means if it is matching, then you do this. If your characters are not matching, so you basically do for start plus 1 end and start end minus 1, and whatever is the maximum value out of these two value, this is again the recursive value, right? Because this will again the recursive value, this is again the recursive value. So whatever the maximum value it will return, that will be your answer, right? So this is the recursive solution that we have. So let's understand that how it will process for this one, right? So here we have this string. Now we want to check what is the longest palindromic subsequence in this. So as per our solution, we check that this is our start, this is our end. Now if start and ends are matching, no, it means it will break into two part, and one part it will be A, B, E, F, B, A, and another part will be B, E, F, B, A, C. Now whatever is the maximum solution out of this one, that will be my solution, right? Now again it will break into, it will check A and A are matching, yes, it means it will say 2 plus again check recursively for B, E, F, B, right? Again B and B are matching, so it means it will say again 2 plus, and now it will check for E and F, right? So E and F are not matching. If E and F are not matching, it means what will happen, that it will basically break into two parts. Either it will be E and either it will be 1 F. Now because both are 1 1, so basically the maximum out of this one is 1. It has also 1 and it has also 1. So what is maximum? Maximum is 1. So it means it will return 1, right? So overall this will return 3. If this is 3, it means 3 plus 2 5. So it means this solution will have 5, right? Now what will happen, that let's check this one. So again how it will happen, this one, then B and C are not matching. Again it will break into 2 1 it will be B E F B A, and another it will be E F B A C, right? Now it will again break, it will break into B E F B, because B and A are not matching, so it will break into 2 1, and it will check E F B E F B A, right? Now B and B are matching, so it will say 2 plus E F. Again it will break into here E and F. So E and F are 1 1, it will say it has one value, it will say 2 plus 1 3, so it means this solution has 3. Now E and A are not matching, it will break into 2 EFB and FBA. Now E and FB are not matching, again it will break into 2 EF and FB, right? So basically it will return 1, it will return 1, maximum is again 1, so this solution has 1. Similarly, where it will break, we know that it will be 1. So 1 and 1 answer, here it again it has 1. So it is returning 3, it is returning 1, so it means overall it will return 3. Similarly, we know that for this, when it will go further, keep on further, there is no such palindromic subsequence, so it will return 1. So it means it will return 3, it will return 1. So maximum is 3, it means this will return 3. So basically you see that for this value we have the palindromic sequence, in this we have 3 and in this we have 5. So overall what is maximum? Maximum is 5 and 3, 5. So it means my answer should be 5, right? So this is how we solve in the recursive solution. Now the point is that can I apply DP here, right? So before checking that, let's check what is the time complexity for this question. Now if you see that what I'm doing, that I'm basically keep on breaking that, and my maximum recursive solution can be 2, like this one. Here I'm doing a complete set of recursive solution, and here again I have complete set of recursive solution, right? So because there it can break in 2 parallel recursive solutions, so my complexity will be 2 raised to power n, right? This is my space complexity. Now what can be my this is my time complexity. What can be my space complexity? So because internally I can use the stack, right, to store the values, because I'm using recursion. So for that value you can say that it is big of 1 n, right? So we have seen that this can be the time complexity if I use the recursive solution. Now the point is, can I apply DP here? Now DP says that you can apply DP only if it follow this property. First is that, is there any overlapping subproblems? Overlapping subproblem says, basically it says that are you solving your subproblems again, right? So if you see like this case, here we solved BEFB, right? Here we solved BEFB, and here also we solved BEFB, right? Now you see here we solved EF and here also we solved EF. It means what is happening, that when we are solving subproblems, we are solving again and again, right? So there should be, so DP says if you have this kind of property, it means I can apply DP here. So DP, what DP says, that I will store the values, whenever it comes again, then I can return the value, that I have that value, right? So yes, we can see that here we have the overlapping subproblems. Now second property, it says that is there any optimal substructure? Is there any optimal substructure problem? So optimal substructure says that can you achieve your final solution if you have the solution of subproblems? So yes, I have here that if I have the solution of both these two sections, then I can achieve the final solution, right? It means it follows the second property as well, that if I have the solution of the subproblems, I can achieve the solution of the final solution, right? So I can apply DP here. Now DP can be achieved by two ways. Either it can be top to bottom or it can be bottom to up, right? In top to bottom, what we do, that we just basically convert the recursive solution. We just say that here what we did, we just returned the value that because we had got the value 3 and then we just return the value, right? So it says that is fine that you are returning the value, but before returning the value I will store that value somewhere, so that if the same question asks again that what is the solution of this one, then I will check that if the value exists already. If the value exists, then just return that. So this is how it will do that will basically in top to bottom solution, this is what we do, right? That we just store the value whenever we get the solution. So if next value again comes, we can just find the value and then we can return. So like once we have found out the value, we'll store the value of this one, and then when this value will again ask, we can just return the value, so that we need not to do all this thing, right? So let me show you so that you can get it better. So here basically we are taking a storage as integer array and we are taking a 2D array. Now in this, so in 2D array will be of length of the n. So if a string has n length, so it will be of n cross n 2D array, right? So this is how we'll store the value. Now you will see the difference. So we say, okay, these conditions are again the same, that if start is greater than n, then return 0, and if start is equals to n, then return 1. So now you see what's the difference. Here basically we were just returning the value, right? But here what we are doing, that if the value is null, if this value is null, it means we haven't found out our value, right? So if this is null, and you see the difference, that we haven't taken the integer, the primitive type. We have taken the object type of integer, because the problem is that if you take the primitive integer, in this case the by default value is 0, right? And there can be a case that where our solution is actually 0, so we don't want to confuse with that. That is why we have taken the this integer object, right? Because in integer my by default value is null. So now it says that if this value is null, it means we haven't found out our value. It means you need to calculate that value. So if it is value is null, it will calculate the value as we have solved again. That if the both characters are matching, then do the same thing, 2 plus LPS top to down, and again do recursively. Now you see the solution. Now you see the difference. Earlier we were not storing the value, we were just returning the value. But here basically we are storing the value into array. We are storing the value into this one, array start end, and similarly here also when the value is not same, then also we are storing the value. Other things are same, the logic is same, it's just that we are storing the value, right? So here also we store the value, array start end, and then maximum out of LPS of this one and this one. Now if the value comes again, then it won't be null, right? Because we will store the value, right? So if it is not the null, so we'll just return the value from the existing array, right? So this is what the difference is. This is how we can calculate that what is the longest palindromic subsequence using DP solution of top to down, right? So if you see in this case, basically our time complexity will be big of n square, right? Because now we are not doing recursive solution again and again. Whenever we have found out the value, we'll just get from the array and then we can return, right? So overall, because we have taken a 2D array, so my space complexity will also be big of n square, right? And my time complexity will also be n square, because we are not doing more than this one, right? We need to solve at least for this one because we are checking each and every case. So that is why my time complexity will be n square and my space complexity will be also be n square, because I am taking an array, right? So it means I have improved the time complexity from big to restore n to n square, right? So this was a top to down solution. Now we'll see the bottom to up solution. So bottom up DP solution says that basically we'll solve the basic solutions, basic bottom solutions, and then once we have found out the solution of the sub problems, then we'll find the actual solution, right? So this is why this is known as bottom up DP solution. So let's say this is my string. Now basically our aim is to check each and every combination and check that what is the maximum longest palindromic subsequence length, right? So let's say we have this case. So can I check something like this, that first of all I can check from here that okay, how many substrings, like what is the LPS here, what is longest palindrome subsequence. So here I have one. Now I can check again like how many maximum subsequence here in this case. Then I can check how many subsequence here. Then I can check how many longest subsequence here. Then how I can check how many longest subsequence here, and then I can check at the last, right? So you see what I'm doing. I'm basically getting the basic solutions, and out of basic solutions then I'm calculating the further, right? So the I can do from this is what I did from the end. I can do from the starting as well. Like I can start from here. Now each character has itself the minimum longest palindrome subsequence will be 1, right? Because itself one character is capable of the subsequence of length 1, right? So what I can do, so basically to solve this question I am taking a 2D array, right? Why 2D array? So that I can check each and every combination, right? So I'll let you know further when we go further in this solution. So first of all, as we have explained, that our basic solution will be 1. Like in this case, this is the same string I have, a b e f b a c, and this is also a same string, but I am representing it as a 2D array so that I can basically check each and every combination. Now first of all, can I write all the diagonal as a 1? Why 1? Because I know that each character is at least one sequence of length, right? It means it will be 1. Then because it is a, this is the same string, this is the same character, again bb is the same character, e again it is the same character, f it's the same character, then b also it is same character, a is again same character, and c is same character. So for this I can write 1, right? Now I can start from the starting or I can start from the end, right? So let's say first I start from the end, then I will also explain how we can start from the end. So now let's say I'm checking with this one, then I'm checking a with c, then I'll pick b, then I'll check with b a, then I'll check b c. So first let's start with the a. So now when I'm at this one, I will start from the here, I will check whether this a and c characters are matching or not. If a and c character are not matching, so what I do, so because if character doesn't match, so what I do, I basically check that what is the maximum out of start plus 1 and start and minus 1, right? Now what is the start currently? My start is 5, right? Let's say this is row and my and is column, so my column is 6, right? So my start plus 1 means it will be 6 and 6, and start and minus 1, so it will be 5. Now what is 6 is this, 5 is this. So it means whatever the maximum out of this one, this will be the solution. It means both are 1, so maximum is 1. So if your characters are not matching, it means this will be 1. Now I am checking b. So first of all, b will check with a, right? So when b checking with a, it means I am comparing b a, that's it. So if I am comparing b a, it means now b and a are not matching, right? If b and a are not matching, again whatever the maximum out of diagonal, that will be your answer. So both are 1, it means it will be 1. So you can see what is the longest palindrome sequence out of this one, only 1, right? Now check with this one. Now b is compared with a, now b will compare with c. Now whether b and c are matching, no. It means whatever the maximum of the diagonal, that will be your answer. So maximum is 1, so it will again be 1. So it means what we are doing, we are checking each and every combination, right? This b we have checked with a, then we checked with c. So when we checked with c, it means in BAC how many, what is the longest palindrome subsequence? Only 1, right? So this is why we are doing that. Now check with this f. So first of all, f will check with b, right? F will check with this b. So whenever I am solving with this any, so look, this is why I started from the end, so that we are in sync with this one, and we started from this one. So when I'm checking with this f, I will start from the I plus 1, because here my I is 3, my start is 3, and my end will be j plus 1, my start plus 1, right? Now check F and B are matching, no, it means whatever the diagonal maximum, that will be answer, so it will be 1. Now check, F and A are matching, no. If F and A are matching, not matching, again the maximum of this one, so it will be 1. Now check, F and C are matching, no, again the maximum out of this one. So if your string was this one, F, B, A, C, again your maximum palindrome subsequence length will be 1. Now check with this one, E. So E and F are matching, no, so it will be maximum out of this two, it will be 1. E and B are matching, no, again 1. E and A are matching, no, it means 1, maximum out of this one, 1. E and C are not matching, no, it means maximum out of this one. And you know why we are checking from this one, because this is about this one, start plus 1 index and then start and minus 1. So basically it will be array, so we can write something like this one, and here also we have array, right? So maximum of these two values. Now E and C are not also matching, so it will be 1. Now check with this one, B. So now B and E are matching, no, it means so maximum out of this one it will be 1. Now B and F are matching, no, it means maximum out of this one and this one 1. Now B and B are matching here. So if B and B are matching here, it means what we do, if it match we say 2, then start plus 1 and minus 1, right? So it means what is start? So start is 1 and 1 plus 1, what is end? End is 4, it means 4 minus 1, so it will be 2 and 3. So what is 2 and 3? 2 and 3 is this one. So what? So whenever it matches, whatever the diagonal value, that just add plus 2 in this one. So like this was 1, it means we'll add 3. So now it is 3, right? So now B and A are matching, no, so whatever the maximum out of this one, that will be your answer, so it will be 3. B and C are matching, no, so whatever the maximum out of this one, it means it will be 3. Now check with this A. A and B are matching, no, it means maximum out of this one, 1. A and E are matching, no, maximum out of this one, 1. A and F are matching, no, again 1. A and B are matching, no, so maximum out of this one and this one, 3. Now A and A are matching. If A and A are matching, it means 2 plus this one, so 2 plus this one means 5. Now check, A and C are matching, no, it means maximum out of this one and this one, and at the last we can return this one. That is my answer. So this is how we are solving our question. We started from the end, we traverse each and every combination, right? You saw from the starting, when we checked for A, we checked for each and every combination. When we did for B, we checked from B to A, B to AC. When we did from F, we checked from F to B, F to A, F to C, right? And at the last we got our solution that this is the maximum longest palindromic subsequence, right? So now if you see the time complexity in this case, basically we solved in 2D manner, right? So my time complexity will be big of n square, and because I have taken a 2D array, so my space complexity will also be big of n square, right? Now let me show you the code as well so that you can get it better. So here I have a solution, LPS bottom up, where I just pass the string and pass the length of the string. So I will create an array. I will create a 2D array of the n cross n length. Now because what I did, I started from the bottom, I will start from the end, right? So this is why I'm starting from I equal to n minus 2, because we started from the bottom, and then I go till the top, means I is greater than 0 and I minus minus. So this is my first loop, will start from the here, and my second loop, my j will always start from I plus 1, right? Because it always check the other diagonal, we are checking the other side, right? So this is why it is happening, because we started from here, we basically started from here, this A, right? Because the C was of no point, because C was it was only 1. So this is why we said n minus 1. N means the length of the string minus 2, basically minus 2, because our index will be n minus 2. So we started from here, and my j always was I plus 1, because definitely if my I is n minus 2, so definitely my j will always be, because we are checking in this diagonal, we are checking in this side, right? So that is why my j was I plus 1, right? So this is how I did this, that my j will be I plus 1 until j is less than n. Now this is the same thing, that if characters are matching, then you basically insert the value 2 plus array I plus 1 j minus 1, right? And if your values are not matching, then you do the maximum out of array I plus 1 j and I j minus 1, and at the last you return the rightmost value, so which will be the first array, first row and the last column, so array 0 n minus 1, right? So that's it guys about this scene. We have checked that how to find the longest palindromic subsequence using a basic solution, recursive solution, and then we saw the DP solutions, right? So if you have any doubts, please write in the comment section. I will try to explain that, and I will also put this source code into description section, so if you want then you can also get it from there. So that's all for this video, and if you have liked the video then please like it and subscribe the channel for more such videos. Thank you.